Hi there, my name is Ryan. This is Project Pi Pancake. It's a short video outlining a proof of concept we did on a stack of 4 Raspberry Pis using 4 cameras, YOLO open source video inference engine, and deployed using Horizon technology, basically putting video inference on the edge. At the end of this project, which is documented more thoroughly on this YouTube channel playlist, by Joe and David and friends that goes through sort of part A through part O on step by step. This video is sort of a big wrapper for the whole process as we built another one of them. Um, at the end of the project, you'll have a Pi stack, as you see there on the right-hand side, 4 Pis with a nice plexi set of covers. In this case, plugged into 4 Sony PS2 cameras that are only $8 each on Amazon. And streaming information from them, from whatever pattern they're deployed, in this case to Grafana. Grafana here on the left-hand side is monitoring the CPU utilization out of each Pi, and on the right-hand side, it's analyzing images using only the power of the Raspberry Pi and counting the number of objects or people in the view and keeping track of them in a people counter. The parts and materials for this, 4 Pis, 4 cameras. On the right-hand side in yellow are still covered are the clear plexi sandwich plates, pancake plates for this. Other cooling apparatus like the heat fins and fans, and then a chunky power supply capable of delivering the current necessary for each one. We're also using an Airport Express as a Wi-Fi and that is necessary to deliver the IP addresses to each one of them so that we can SSH from our Mac into each one of the devices and have our own little local network. Here's the bill of materials, Amazon's parts list, the 4 Pis, and of course the SD cards. We've got 32 gig micro SD cards that we can burn and flash the image onto. The cluster case assembly, great little assembly. I got a 10-pack of USB cables because they were on special, and then a beefy USB power supply that's available, and 4 Sony cameras. I didn't put any of the networking device on here. Some of you may want to use Airport Express or hardwire it into some other network device. That'll be out of scope for this conversation today. So where do we go to get the image that we want to flash onto our SD cards? Well, Raspbian here. Let's go and find it. Can't see my mouse, so I'm going to be fumbling around here a little bit. There we are. So on Raspberry Pi, make sure you download the Stretch Lite, Raspbian Stretch Lite. The image size is about 351 megabytes, just over 350. You can pull that down and then put it locally. Once you've downloaded it and have it local, your next stop will be Etcher or a similar program. We've used with success Balena Etcher. And the website for Balena is here, and it's worked quite well for us. And Joe outlines pretty well on the videos the process for this. That's part B that we're now to in the step-by-step process here. After Balena and burning each one of the cards, we want to apply the hardware and the heat sinks. There's 2 silver finned versions that go on the top and 1 copper top that goes on the bottom, and you just apply those carefully. And again, that video is part C in the playlist there. And then get in and start stacking. Get your fine fingers out. If you've got a little mini socket along with a screwdriver, that can make life a bit easier. If you are a stickler for detail, note that the orientation and the location of the circles, cutouts for the fans on the plexi, they're not perfectly in line with the center with that notch on the side. So if you want everything to line up perfectly and look good, just pay attention to which side you've got up and do a little testing before you bolt it all together. The fans will require power. You can plug them into pins 4 and 6. Note that there's a 1-pin offset there in order for it to miss the first 5 volt and get 5 volts to the red and ground to the black on here for the fan power. And then power up and configure. login is Pi and password is Raspberry. You'll want to change this. Don't sudo do your password update as your Pi user. And then you're going to want to sudo raspi config and go in and do a couple things. First thing is to go and turn on the interface options and enable SSH. And the second item, which is not shown here, is go in and get hooked up to your Wi-Fi, to your network. As I said, we used an Airport Express base station, which issued IP addresses and allowed us to connect internally. We got the IP address of each device by still using the keyboard and the HDMI monitor into each one of the devices, and go in and type ifconfig, and you'll see if you're on Wi-Fi, WLAN 0, and in this case 192.168.1.250 in the left-hand side there. It allows us to SSH in from the Mac, and then we don't have to plug in keyboards and monitors anymore if we don't want to. And here's what I ended up with in terms of IP addresses. You should have a 192.168 prefix or a 10.x prefix, depending on how you've set up your network. And I gave my devices gold, silver, bronze, and copper in order from top to bottom of each one of these. And you can see, actually, we'll hop ahead and go have a look at Grafana. And that's me chatting away to you there. And you can see on the right-hand side, we can see people counter gold, silver, bronze, and copper from top to bottom. And those are the images that are coming from the camera right now. So each one of those pies is currently running video inference, the YOLO model, and counting the number of objects, including people, in the field of view. You'll see here on the top on gold is I unregistered about 10 minutes ago, the top one. So that's a bit of old information from about 10 or 13 minutes ago. The other three are happily humming along right now. So we're going to reactivate that pattern here shortly. So when you're installing fresh, you're going to need to get Docker on the Pi. So sudo and then curl this command from getdocker.com, which is here. And it'll run this script for the easy installation of Docker. And if you've done it right and you do Docker version, docker.v, you should see something that comes up and looks like this. Okay. Now that Docker's on, we want to install Horizon. There's some documentation on this link here under Annex. I'm not going to go too deeply into it, but it is a mechanism for orchestration, authentication, and agreement and negotiation of these patterns that we're about to deploy. Here's a screenshot from the public website that goes through step by step on the installation of Horizon, and it's pretty good stuff. We've used this script, which seemed to work pretty well. I'll put it in the comment section. Again, sudo for root. Here's the script to run to do the installation. And this script effectively adds Blue Horizon repo and the packages, and when you're done, the Blue Horizon will be installed. And you can go in and test this by doing HCN node list. And you should get something that looks like that, indicating that Horizon is installed and ready for action. And then we need to get some files onto the Raspberry Pi, so we can SSH into each one of these IP addresses, which we've saved, of course, and then STP copy the files from the directory into each one of your Pis. In this case, we've got a bunch of files that relate to YOLO for the image recognition, and then there's another simpler pattern which encourages the device to report its CPU percentage utilization. And we've got some shell scripts to switch between one and the other one and quickly show the reconfiguring of them. So the mycreds, two files that are necessary before we actually run the Horizon command are the mycreds, which have org IDs. How you get these org IDs are documented in other parts of the documentation, so I'm not going to go into it too much here, but you can see the flavor of what it looks like down on the right-hand side with some of the details obscured. The other one is the input.json. This is what the CPU to message hub looks like, and there's a similar JSON for YOLO. And with that, we can run a script, or we'll we'll go through it manually here. So I'm going to run the script. I'm going to copy the YOLO micreds to micreds and the YOLO input to input.json. I'm going to source the micreds, and then I'm going to actually do the registration here. So let's go do that right now. I'm just going to make sure that we're not running anything as an agreement list. HCN, make sure it's not configured. There's nothing there, so there's no agreements in place. This device, I unregistered it before I started the video, so it is a blank slate waiting to be configured by Horizon. So let's go and do that. So I'm going to go in here, and can't see my cursor, so here we are. So we're going to copy micreds, actually I'm in the wrong one here, so let's go here. All right. It's tough to navigate when you don't have your thing. So let's do ls. So we're going to do cp, copy, YOLO micreds to micreds. And then we're going to copy YOLO input.json to input.json. And then we're going to source. And then we're going to run our Horizon register. And if we're lucky, Horizon will orchestrate the loading of the YOLO pattern and deploy it to here. And we're going to get ready here. We're going to watch a play-by-play and watch the agreement list unfold. So HCN. So you can see here the workload agreement negotiation should begin shortly. And we'll do HCN list. Nothing yet, and in about 10 seconds, the initial agreement should appear. It'll start with a creation and then an acceptance, usually about 5 or 6 seconds afterwards. Let's go now. There we are. So there's an agreement ID with the AgBot, the agreement bot. We can see that YOLO message hub pattern is here, and the creation time was at 4:31:59 GMT. And then let's have a look now. And already, after the agreement was created, it was accepted about 8 seconds later. And then shortly after, there was a finalization. And this pattern's a little beefier than the other CPU ones. So it might take 20 or 30 seconds for it to start. But once it starts, it will begin, and it will begin to operate. And because it's a Raspberry Pi, it takes a little while to process. There's usually about a 60-second time between the image being taken and the processing happening. Let's have a look here, and the pattern is already executed now. So now we have all 4 of our Pis up and running again, and let's go have a look here. To Grafana, and in about 60 seconds, we should see the data point appear on the gold, and as the data starts to come in. So while we're waiting, let's go and have one more look at our agreement list. Yeah, we're up and go, and we're executing. And if we want to unregister, then rinse and repeat or deploy a different pattern, HCN unregistered will unregister the node and create a blank sheet of paper, a blank canvas for us. And you can check it's been unregistered by typing in the HCN agreement list again, and you should see an empty set of brackets there rather than what we see here. And then go ahead and do a new pattern if you like. So we are up and running. Let's go and see if we are getting any data yet. Not quite yet. And if we're lucky, we'll see something in the next sort of minute or so pop up here, and we should see an image as well of me chatting away to the top camera on the top Pi. This data, these thumbnails and the data here is going to Grafana. That'll be covered in another video, but it's a great tool. I've been really impressed with it. Very versatile, very easy to share and set up as well. And I think, oh, there we are. We got our first image. And there, my head was cut off, so it didn't quite, oh, I see the camera's tilted up. Let me tilt it over here. But we are up and rolling, and now we've got 4 patterns that are up and running, deployed by Horizon, and there you have it. So thanks for watching. As I said, there's more detail and very good documentation that's available and more granular videos that are available as well. But this is just sort of the big old wrapper to go from zero to completion. So thanks for watching.